Okay, guys, welcome back to the channel. For those who don't know me, my name is Maxwell. Yeah, okay. So today, basically, what we're going through is we're going through an introduction to Vulkan in the Android environment. Uh, what you would expect to know by the end of this video is I would have shown you how to draw a polygon with at least 6 vertices, and I would have demonstrated to you at least a one-line drawing algorithm, either the Bressenham's line algorithm or the DDA line algorithm. So first things first, let's first get started. Uh, Normally, at first, when you're joining or when you're new to Vulkan, the most simplest way to get started immediately is just to use a template tool, which you can get to by actually just going to file and going to the new section and importing either the module part or the sample part. Yeah. So for beginners to Vulkan, that would be the fastest way by just using a hello VK file to template to just kind of give you a template of the basic code and Vulkan samples for you to try out on your phone. Yeah. So first things first. So I went ahead and took that step. So first things first, I also have my Android connected. Yeah. Okay. So first things first. For us to draw a polygon, we normally have two most important folders, which are most important to us in as Vulkan uh, 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 Vulkan students. Yeah. So the first thing that we have is the hello vk.h file. That is if you've used the sample template. And then we also have the second folder, which is the shaders, where we have a file called the shader.vat. So basically, these two files are the ones which are going to be of most importance to you. Without the customizations, uh, just by running the basic hello vk template, when you run it, it will run on your Android and show you some sort of triangle that will be formed, which is what I'm going to be using to as the building block in making as the building block, sorry, in making the polygon. So first things first, what you need to do is actually to first things first is actually have to go to a hellovk.h and we have to search for a function called the CMD draw. Basically, we're going to be making a polygon with 6 vertices. So if we can divide that, I'm not sure if we can divide that or I can give you the polygon details. Basically, the coordinates are 8, 4, 2, 4, 0, 8, 3, 12, 7, 12, 10, 8. So the first most important thing about Vulkan you need to understand is that the scale runs from 0 to 1. So whatever coordinates have been given there, no matter how big they are, you have to sort of divide them with a certain number of scale for them to fit within that range of 0 to 1. In my case, given the range of numbers, I'm not sure if I can show you the text. Maybe I'll put a link down in the description below. Yeah, so basically the largest number in my set of numbers was actually 12. So what I did was I went ahead and divided every number in the coordinates by 12. So given if it's 8, 4, where 8 is the x coordinate and 4 is the y coordinate, divide both by 12 just to get the sorry the to get the scale between 1 and 0. Yeah, to get the scale between 1 and 0. So as I was saying, the first things first, you want to do in this hello vk.h file which can actually be renamed, which I'll rename is we need to find a function called the CMD draw, the VK CMD draw functionality, where this functionality is where basically we input how many vertices we're going to be having in the polygon. The rest of these parameters are just the initial vertex and the instance of the vertex. I'm not sure if this can show that. Yeah, so basically we need to search a CMD draw and look for the CMD draw functionality, which basically is responsible for rendering all the graphics in the simulation we're going to be doing. So once I've done that, I remember I'm not sure if I can draw it for you, but if we have a polygon of a six-sided polygon, we divide the polygon into four triangles. You can remember the first thing I said is that when you run the basic VK template, you get a triangle formed. So basically, like the basic building blocks of this the basic building blocks, of this polygon will be a group of four triangles, which are going to be drawing from the bottom left to the bottom right to the top right, following that order across the entire polygon. So given whatever coordinates you may be given, you just you can sort of plot this on a graph and kind of sketch out some triangles that you would want to draw, starting with the bottom left to bottom right to the top right, repeating the process until you've covered the entire scenery of the figure. So yeah, so in our hellovk.h file, basically we just had to modify the CMD draw functionality, and then over here on the shader.vert is where now we actually input our vertices. Yeah, so sorry about that. Yeah, so let's go to our shader.vert. I'm not sure if you can get to that. Yeah, just right there. So basically, in this shader.vert file, basically we first have the basic layout code, which is right over here. This is just the version of the Vulkan configuration file. Yeah, so basically, the most important things over here are actually is actually this block of code right here, like two positions at 12. If you can remember what I said, is that we're dividing a polygon into 6 sides, which is we're dividing our polygon into 4 triangles, sorry, which has 6 vertices. But remember, we have to keep on drawing these triangles for every part of the polygon, which is a bit repetitive, but it's necessary for the graphics to be rendered. So yeah, so basically we're going to have, if a triangle has 3 vertices, so if you have 4 triangles and that would be 4 times 3, that would be 12 vertices that will be actually drawing. Yeah, okay, so yeah, so this just yeah, so this is just the code for the positions of the triangles, sorry, the triangles. Yeah, the next bit of code over here is actually the color, the colors of the polygon, where we have the basic color of the polygon that is going to be drawn, where we define single color for the entire polygon. There are 2 ways to do this. You can either dedicate an entire single color to the entire polygon, or you can actually plot out for each vertex of the polygon which color you actually want it to be. Yeah, so in my case it is basically this is basically RGB. So this is red 1, red, this is red, and 0 green, and black. So basically we are going to be having a red color in that. Yeah. Also, just a minor note, in the vk.h file, just for it to be rendered, there's actually like a bulk of code that needs to be run, which is about 1,000 lines, which I wouldn't recommend to any beginner starting out to be writing 1,000 lines of Vulkan C++ code just to get a simple structure formed. So that's why I will actually use the template just to make things easier. So I think now it's best that we can get to running the code. Just a minute. Okay, just a minute. Okay, so let's get to running the code. This is done simply. Basically, what we normally do is just if we can first make the project, and then we build and then we run the project. Yeah, so basically what we're doing is we're just waiting for it to build. It might take a while, so let me just pause right here. Okay, so yeah, it's done building. Let me just reconnect back to my device, and then yeah, we can run the application. So basically we just run it from over here. I'm not sure if you can see my screen. Yeah, so basically this is how the polygon looks. If you go back to our shader.vat file, you'll realize that this polygon is actually made up of 4 triangles. But remember, I told you that you can actually draw out the actual polygon onto a graph or something, or a piece of paper with the accurate scale, and actually map out which triangles you want to draw. But remember, following the criteria of actually from the bottom left to the bottom right to the top right, repeating the same pattern until you've covered all the triangles in the polygon. Yeah, I'm just having a little bit problems with connecting it, but basically, yeah, this is how the polygon is supposed to look. Yeah. And now let's go to our second part of the video, which is talking about line drawing algorithms. We're going to be talking about actually the Besenham's line drawing algorithm. Yeah, so there are actually 2 ways of doing this, but first let's get to the Besenham's BK file, and then I'll explain more when we get there. Okay guys, so now we're on to the Besenham's line drawing algorithm. Basically, this algorithm involves it basically demonstrates how actually computers draw lines, which to the common eye may look like a single line, when actually it's a series of dots and a series of patterns. Yeah. So I was still using the same template that we had used at the LVK just to minimize the complexity. So for the Besenham's line drawing algorithm, now there are 2 ways of doing this. You can either calculate the code, the vertices that you need for the line, or we can actually do this manually, which involves actually calculating the actual vertices and actually plotting them using the vertices shown in the previous example, which is in the shader.vat file. So first things first, in this file, we're going to go ahead and press Ctrl F and search for, we're going to search for a file called line in this code called a topology, which this basically means is how basically how we are rendering it basically explains how the graphics are rendered. Like in our previous example in the triangles, if you can check the code, which I'll put in my GitHub, you'd see that the topology is actually a VK primitive, but it's actually a triangle. Yeah, so what we do now is we actually change this from the triangle, which it will be originally, into the topology of the line strip. which is more similar to what we're trying to draw with the line drawing algorithms. Yeah, so there are two ways of doing this. You can either calculate it using a code, C++ code, and yeah, we can either do this to calculate it with the C++ code, or we can do this manually. I'm going to have both examples of my code, but for now, let me just show you the actual manual partitioning of it first. You can find the automatic, the automatic code for calculating the vertices in my project structure. Yeah, so we'll just go to the shader.vert. Once I've changed this to line strip, we'll go ahead and calculate the lines starting from a point. Let me just confirm the points. For present harms, we'll be calculating from the point at 3.4 to the point 4.8. Yeah, so in a shader.vert, first things first, remember the axis for the plane in Vulkan is actually between 0 and 1. So what we're going to be doing is dividing the 3.4 and 4.8 to fit within these coordinates. Yeah, so this is actually done manually. So what we're going to do is we actually calculate the values of the Bresenham's equations manually, and then plotting the values over here. So finding this over here. Yeah, basically the code structure is basically the same with the polygon code structure, where we have the vertices, positions, and you have the colors, which I said you can either do it singly as it's done over here, or just giving it a whole color at once, a single color for the entire structure, which is mainly not advised in the documentation for if you're trying to render more particular scenarios. Yeah, so I'll just write over here. This over here is our starting points. Just from over here. Yeah, basically what we're doing is we're just plotting the code manually that we had calculated, which this actually can be found in the resources of if you just Google how to search how to actually calculate the Bresenham's line equation, it's actually quite an interesting process. You can actually just do that. So yeah, so basically we'll just be plotting those points that we get over here. In my case, I had found 7 points, hence the 7 vertices. By the way, something that I forgot to mention in the previous example, this array over here should always match the number of items inside in this function over here. So basically, if it says 7 over here, this also should be 7, which is just basically, yeah, this is our main function. Yeah, so after plotting that, let me just run the code right now, and then we see how this looks like. So first things first, we always have to build the application. If you already built the application, there's no need to build, so you can just run it again. So in this case, in my case, I already built it, so let me just run the code. Just give me a minute for me to set up my actual emulator. Just a minute. Yeah, so let's run the code just briefly. Yeah, so let me just reconnect that, and then we can run this code. Yeah. Yeah, as you can see, I'm not sure if you can see that. Just a minute. If you can zoom in on that. Just having a few problems over here. Yeah, as you can see, the line has been drawn over here. Just a minute. Let me just. Yeah, so when you run your code, you actually see the figure right here at the bottom of my screen. I'm not sure why it keeps on recollecting losing code, but yeah, basically this is the code this is what the line would look like. Basically, when we're drawing it from the pointer 34 to 48, it will look like that. That's actually the manual part. So what you're going to find in the code is actually the GitHub code is actually the actual implementation with the auto uh, compute part of the code. Yeah, and that's it. Just for a brief introduction to Vulkan in Android. If you have any questions, comments, just let me know. Yeah, and it's been Maxwell. Yeah. Yeah, so I'll see you guys later.